gotta do that video. Hey James. Yeah, I really need some help with this video. Are you free?
I'm making the oral presentations video right now. It's for the entire school and it's gonna go up next week. I can't...
I'll just do it on my own, man.
Okay, thank you. All right, well, good luck. Bye-bye.
All right, hello, ninth graders. Today we're gonna learn about linear equations. We're gonna learn about how to solve them. We're gonna define how a equation compares to similar vocabulary, and we're going to go ahead and graph them. All right, so this is a competency that you will need in order to move on to the 10th grade. All right, first up, we got to do now for you. So I want you to get out your pen, your something to write on, like paper or a notebook, and give this a try. So number one, what is an equation? And number two, what is the difference between a one variable equation and a two variable equation? So pause the video and give that a try. All right, I hope you gave that a try. So our first step here, an equation says that two things are equal. They can be two quantities. They can be two sides of an equation with multiple variables. So you can have simple expressions or more complex expressions, but it's just saying that two sides of the equal sign would be equal to each other. So our next one would be, for example, if you were to say Abdussamad equals a Barso student, is this true? So we could categorize Abdussamad as an Barso student, right? But Abdussamad is much more, right? Has many more dimensions to himself than being an Barso student. So you couldn't really say this is equal. And in mathematics, two things are equal only if they're the exact same in every way. So no, we cannot say Abdussamad equals a Barso student, right? They're different. A Barso student is just one dimension of what Abdussamad represents. So number two, what is the difference between a one variable equation and a two variable equation? So one variable equation, there's only one variable on either side of the equation. So that would be x is equal to 2. That's a one variable equation. A two variable equation, there are two variables on either side. So that would be when you're involving x and y, or a and b. All right, so now we're going to look at some equations without variables. Which of these are true? So pause the video and give it a try. So 7 is equal to 5. That doesn't really make sense, right? We know that 5 would not be called 5 if it were equal to 7, right? 5 represents a different quantity than 7, so that is not true. 120 is equal to parentheses 5 times 4 times 6. Now for this one, if we multiplied 5 times 4 together, we get 20. We multiply that by 6 and we get 120. So that is true. And then now 130 divided by 20 is equal to 0. Now we know that 130 divided by 20 is going to give us some quantity other than 0. If we actually work this one out, it becomes 6.5, and 6.5 does not equal 0. So we know that is not true. The only thing that can equal 0 is 0, right? And then finally, our last one, 10 is equal to 10. Well, that's true, right? 10 is the only quantity, right? Only number which equals 10. Okay, and this might seem redundant, right? Why would we even write 10 is equal to 10? We know that, so what's the point of really doing it? And that is really why we use equations to solve for unknowns, to solve for some variable, right, that we don't know. Most of the time it's going to be more than one variable, but in this situation, we're not going to see equations used as much with just numbers, right, like 5 and 7 and 120, because it's a given, right, that the only value that 10 can equal is itself, 10. All right, so now we're going to look at linear equations as they're graphed, right? So if we graph the relationship between x, right, and y, two variables, which are the most common ways you will see two different variables represented, right? So x you will see represented on the horizontal axis, y you'll see represented on the vertical axis. And so for this one, in the linear equation graph to the right, when x is 2, right, when x is 2 here, y is also 2. So our equation comes to y is equal to x, because we also know when x is 0 and y is 0, right? And when x is 0, y is 0. We also know when x is 4, y is 4. And so we know that our equation can just be set up as y is equal to x. All right, so the parts of an equation. So there are some special names, right? You know that x, right, is known as a variable. you know from some of our last videos that an operator is really just a symbol such as plus, the multiplication sign, minus, that is in operation, right? It shows we want to do something with our quantities. So a term is either going to be a single number, like 7, right? Or it's going to be a number in a variable, or just a variable. So it's really anything that you can combine with an operator to get an expression, right? Which is a group of terms, right? And the only way you can have a group of terms is if there's some operator that is combining them in some way. It could be, like in this example, 4x minus 7 becomes an expression because minus combines the terms 4x and 7. It could be 4x times 7, right? Where the operator is multiplication. And then our terms become, like in this situation, 5, which is on the right hand of the equal sign. It could be 7, or it could be 4x. All right. And finally, our coefficient. So our coefficient is going to be any quantity that is multiplied by a variable. So any quantity that is multiplied by a variable. So if I have 4x, my coefficient is 4. If I have 3y, my coefficient is 3. All right. Next up, we have the basic properties of algebra. So we're going to go over the 4 main ones for right now. And just to review, how does setting up an equation, what are the rules by which we can solve an equation? So the associative property is when you group two numbers and you add them. It doesn't matter what order of grouping you use. Now, you'll remember from our PEMDAS video 2 videos ago that 3 plus 4 times 7 is going to be different than 3 times 7 plus 4, right? Because when we're going left to right, that's going to change our equation. So this is only talking about addition or subtraction. So when there's addition or subtraction, it doesn't matter what order you add them in. When you involve multiplication into that expression, then it matters. But in this situation, 3 plus 4 plus 7 is the same thing as 3 plus 7 plus 4. And then the commutative property. So similar to the grouping, whether it's grouped in the parentheses, this one is just saying, if I have 3 plus 4, that's the same thing as 4 plus 3. There's no difference. All right, and then next we have the transitive property, which is going to be A. If I have A is equal to B and I know B is equal to C, then what also has to be true is that A is equal to C, right? So that would make sense. So if I say that, let's say Bob is 5 miles away from the school, and Sally is 5 miles away from the school, then Bob's distance and Sally's distance have to be the same, right? All right, so finally we've got the distributive property. So parentheses indicate multiplication. So if I say parentheses, like here, 4 plus 3, and then immediately outside the parentheses is a 5, then what I'm being asked to do, based on the rule of what I'm supposed to do with parentheses, is I'm being asked to distribute this 5 into the equation. And so you can multiply 5 by whatever is in there. So this would be, I could do, instead of solving 4 plus 3, there are some situations where I cannot combine the terms that are inside the parentheses because they're not like terms. So like in the bottom example, we have 3 parentheses 4 plus x. Now I cannot combine 4 plus x. I can't simplify that any further. But what I can do is I can pass along the 3 to both parts of this expression. So instead of 3 times 4x plus 3 times 4 plus x, this becomes 12 plus 3x. All right. Now we're going to take a look at this problem right here. So we've got x minus 2 is equal to 4. And so in order to do this, in order to do most algebra problems, we're going to be using the property of equality, which basically just means whatever you do to one side of the equation, you have to do to the other to make it equal. So x minus 2 is equal to 4. If I want to get x alone, and I want to find what value x has to be for this equation to be true, then I can subtract 4 from both sides. Okay, I can go do x minus 2 minus 4, and that will give me the same thing as x minus 6 is equal to 0. And then I can add 6 to both sides, and finally I get x is equal to 6. Now you can do that a shorter way as well. You can say x plus 2. You can do, instead of subtracting 4 from both sides, you can add 2 to both sides, and it would be x minus 2 plus 2 is equal to 4 plus 2, and then the 2's cancel out on the left, and you're left with x is equal to 6. So my first way was a bit longer than you need to do it, but either way, you want to get x alone. And so our final answer is x is equal to 6. All right, so now we're going to try some examples. So we have the first example, 3x plus y is equal to 4. So we want to solve this equation in terms of x. We just saw the definition of term is a part of our expression that is alone, separated from an operator. So that would be, in this situation, we've got 3x as a term, technically y is a term, and 4 is a term. So we're not solving it in terms of 4, we're not solving it in terms of y or 3x, but we're solving in terms of x alone. Okay, so that means x should be alone on one side of the equation. And in this situation, we're going to do the same thing, except we're going to solve the equation in terms of y. So 4y plus 11 is equal to x. Let's solve that in terms of y. So go ahead and pause the video, and then we will come back and look at it together. All right, so now that you've had a chance to look at that, let's go through it. So we have the first step as subtracting y from both sides. So 3x plus y minus y is equal to 4 minus y. The y's cancel out. We get 3x is equal to 4 minus y. Now we want to divide both sides by 3 to get x alone. And so 3 divided by 3 is 1. 1 times x we can just write as x. And then we get parentheses, x is equal to parentheses 4 minus y, close parentheses, divided by 3. All right, for our next one, 4y plus 11 is equal to x. We're trying to get y alone, so we're going to subtract both sides by 11. Okay, so that's going to become x minus 11. And then we get 4y is equal to x minus 11, divide both sides by 4, and we get our final answer, y is equal to x minus 11, in parentheses, divided by 4. All right, next one, graphing. So what's the point of graphing? Why do we do it? So the answer, right, is that it helps us to visualize. It helps us to really see the relationship between two variables and see the relationship between things in an equation. So it also helps us to identify specific values of x or y. So here I can look at the value of 1 or -1 or -2, and I can see the value of y at any time. All right, now, so how we're going to graph is we're going to use the Cartesian coordinate plane. So it's kind of a complex word, but this is the Cartesian coordinate plane. And it really has two axes, just the x and the y axis, that help us to plot a linear function. All right, so the first thing that we're going to do is we're going to learn how to graph a linear equation by points. So if we have y is equal to 3x plus 4, one of the first things we can do is we can just plug in values of x and output values of y. And so if I plug in 1, here, then I will output, this becomes 1, this 1 times 3 is 3, plus 4, that becomes 7, and so I would go to 1, and then I would go up 7, and I would plot my point here. And the next one I could do with 0. We know that if I plug in 0 here, my y value would be 4, so I could plug in a 4 here. The next one I could do is I could go for -1, and so -1 times 3, that would be -3, plus 4, that would be 1. So -1, my value is going to be 1. Okay, and I keep doing that until I've drawn a line that at least goes across the y-axis. And so normally you'll want to draw that line across the graph you're given and make sure that it crosses both axes. All right, and then graphing the linear equation by points for the second one, we want to turn this x plus y is equal to 7 into a better form. So we're going to get y alone on the left side. The way we do that, we subtract x from both sides, and so this becomes y is equal to -x plus 7. And we do the same thing we did for the last one. We just say, okay, let's plug in 1. -1 plus 7, that would mean when x is equal to 1, y is going to be equal to 6. And then we do it again. We say, okay, what about when y is equal to 2? When x is equal to 2. And then we get -2 plus 7. So when x is 2, y is equal to 5. And so we could keep doing that, keep plotting each point until we have enough to fill the graph. So as you can see, there's our top linear equation being graphed, and there's our bottom. All right, now we're going to look at graphing by the slope-intercept form. So in this situation, you're going to want to graph with looking at the specific form. It's going to be a quicker way to do it than doing it by points. So the slope-intercept form is based on the two main parts, which is the slope, which in this situation would be 2, or m, and then the y-intercept, which would be b, or in this situation 7. And so the y-intercept is going to be where the equation intercepts the y-axis. So here, when our x is equal to 0, when our x value is equal to 0, our y is going to be equal to 7, right here. And so that's going to represent our y-intercept. Now our slope is going to be how many y units, our equation increases by every x unit. So as my x unit increases by 1, what that means is that my y is going to increase by 2. Okay, so I'll start at 7, and then when I increase it by 1, I go to 1. I'm going to have a y value of 9. If we plug that in, we plug in 1 for x, that becomes then 2, and then 2 plus 7, that becomes 9, so it checks out. All right, now we're going to put the linear equations, I want you to put these linear equations in slope form, and then try to graph them. Okay, so pause the video and try to do that. All right, so here you can see the different equations graphed. Remember, we're going to want to get y alone on each side. We're going to want a coefficient in front of our x to represent the slope, and then we're going to want some constant which is going to represent our y-intercept. So here, y is equal to negative 3x plus 8. So as you can see, our plus 8, this red line, is going to represent that graphed function. And then 9x minus 4 is equal to 6. So here, this is a one-variable equation. And so here, if we add 4 to both sides, this becomes 9x is equal to 10. And then we can divide both sides by 9, and x is equal to 10 over 9. So as you can see, this blue line that goes straight up and down, that is going to represent our equation for number 2. Our third equation, finally, we're going to want to get y alone. And so we're going to subtract 2x from both sides. So it becomes 4y is equal to negative 2x plus 16. And then you can divide everything by 4. And so what we get is we'll get 4 as our y-intercept, and then we will get a 1/2. A negative 1/2 is our value for our slope. And so that'll be this green line here. All right, that's it for today. Look in the description and look on the Google Classroom for a quiz to test your abilities. Remember, this is a competency that you'll need to know to move on to 10th grade math, and we will see you next time. Let us know if you have any questions. Thanks. Bye.